Despite a lot of hype, here is a secret reality of today's tech world. Most organizations that have been successful in deploying AI solutions in production have done one thing right. Implement Retrieval Augmented Generation (R.A.G) architecture. Though it is a very simple technique, it can solve many powerful use cases. So, it is very important for every tech builder, including job seekers, working professionals, and organization leaders, to nail this right. At CareerLink, we teach AI enthusiasts essential AI skills to solve real-world problems. We start with foundational AI concepts to architect and build real AI applications and run them reliably at scale. In this video, we'll focus on how to architect and build AI applications using Retrieval Augmented Generation technique. We'll cover how to ingest data into a vector database and how a user's query triggers a semantic search to retrieve the right context. Finally, we'll demonstrate how combining this context with the prompt enables the AI to generate accurate, high-quality responses. Today's discussion relies heavily on groundwork we have laid in previous videos. We recently released a comprehensive video on the mathematics powering LLMs. We also have a dedicated tutorial explaining the mechanics of semantic search and vector embeddings. Additionally, the initial video of our math series provided a deep dive into fine-tuning. We hope you watch the videos and have a good understanding of the concepts. By the way, we also appreciate you subscribing to our YouTube channel and supporting us. For now, let's recap and connect these concepts together. Semantic search allows us to search from large amount of unstructured data, documents, articles, web pages stored in organization, typically in a vector database, by understanding the meaning of the question. For instance, let's take an example of an employee in an organization asking a question. Well, if we use semantic search for the answer to this question, we may get hundreds of matching documents created from different departments of an organization. It may return many of these documents that are similar, but that doesn't mean they are accurate. Semantic search answers what is similar to something very well, but similarity doesn't mean correctness. Now let's move on to LLMs. Large language models, LLMs, allow us to search information from the internet and craft an answer to a question. It doesn't store actual data, but it mimics the human brain understanding public content from the entire internet. It will not know any private information from your organization and answers only from the internet. We don't want employees to get responses to these type of questions from the internet. This is the first and big limitation of LLM for practical use within any organization. Well, you might be tempted to fine-tune it with organization data. Fine-tuning allows us to customize the AI model brain that mimics the internet from additional data specific to a domain or topic area of the organization. However, fine-tuning large language models with your own data is a very resourceful and cost-intensive work. Also, think for a moment what will happen when you update your contents. You will need to fine-tune it again. That's not very efficient and it's impractical. The second big problem with large language models, LLMs, with or without fine-tuning, is they hallucinate and make up answers You don't want your employees to get inaccurate answers from official tools and lead making wrong decisions. That will lead everyone into legal conundrum. So here is the summary. Even though each of these technologies are very powerful, they have their shortcomings. However, we can connect them to build many reliable and practical solutions. Let's observe how a R.A.G architecture handles a specific employee request. When a client asks if they can expense a $1,200 monitor, the framework intercepts the query, and instead of sending it straight to the AI, it initiates a semantic search within the company's private vector database to retrieve the actual spending policies. Then the context is bundled with user's question into a single prompt for the large language model. Armed with those facts, the AI then generates a grounded response, correctly rejecting the request by citing the specific $800 limit found in the documents, ensuring the answer is both accurate and compliant. In this case, semantic search will provide matching records, but also the LLMs will apply necessary reasoning to provide relevant and correct responses to the users. Most companies who figured this out became quick to adapt, implement, and deploy a number of R.A.G solutions in production. R here denotes for retrieve information, which means using semantic search based on the meaning, not just the keywords. The letter A for augmented, LLM reads the retrieved info, also known as context, and applies reasoning before the final generation occurs. And finally, the letter G for generate response. LLM generates new text using retrieved information and internet. Each of these steps are abbreviated for retrieval, augmented, and generation. The simple concept of R.A.G is so powerful that it allows an AI to answer a customer's question by pulling the exact policy, contract clause, or support ticket from a company's database, just like a human employee would. In our next video, we'll try to build an actual R.A.G solution ourselves, beginning from scratch. We will discuss how to implement semantic search for that solution. This involves writing code to read, chunk, transform, and store information in scalable vector databases with continuous data refresh for any changes. Next, we will cover how to integrate large language models, LLMs, through model service providers. We will write a system prompt asking it to return results based on facts with document links. We'll also create a simple front-end application, a React-based app with a text box, response area, feedback option, as well as the conversation history. We'll build an entire R.A.G-based application in less than an hour using Google Anti-Gravity. But for today, that's it. We have an upcoming circle on R.A.G on our CareerLink platform. So if you wish to get a hands-on demonstration of how R.A.G works, please make sure to visit our platform for more information. Furthermore, if you wish to learn more such topics, visit careerlink.ai to explore our circles, resources, and upcoming summer programs for high school and college students. Our unique teaching concept of AI circles will ensure that you learn every AI topic efficiently and with real use cases, implementing real AI tools. Thank you.